Oh shit. It's tutorial time! My mic was off. Very, very silly of me. Anyways, so today we're going to be getting into doing the debugger, writing a debugger, and what we'll be debugging is the array list, an array list. That's what we're doing, that's how we're doing it. So getting started, first I've got some slides to explain exactly how the debugger works, what the difference is between a debugger and a tester, and how all that goes. I understand today is also the last day of assignment 1, so if any of you guys have any assignment 1 questions, I'll leave the floor open for you guys to ask before I get started, because I'm sure there's a lot going on with assignment 1. Yeah, hi. Yeah. Okay, so dot equals is something that compares the fields of an object. So you know objects are defined by a set of fields which you write, which are the variables inside the object. And equals equals compares memory addresses. So dot equals is designed to compare the values of objects, whereas equals equals is designed to compare if literally an object is the exact same one in memory as a different object. So you could have two objects which are completely identical in every way, but equals equals can say that they're not equal because they're not pointing to the same place in memory. And then dot equals is comparing the actual fields of the object. That would be, if you want a lot of detail on that, you could see, I believe, either tutorial 1 or tutorial 2 recording should go into that in a decent amount of detail. But that's the quick rundown of it. So you basically want to use dot equals every time you're comparing anything but the memory addresses. For sure. Alright, well if there's any more assignment 1 questions, I'll welcome them throughout the time, but we'll get started in talking about debugging and testing. So let's get to the slides. Today's goals are to first solve compile time errors. Those are the kinds of errors which you just don't let your program open. And those are pretty common, especially when people are just starting out, right? Like these kind of errors are what get a lot of, like we see them a lot in office hours, and they're just when your program won't open. We're going to fix crashes and exceptions. Crashes and exceptions are when your program literally stops working after it opens. Or if something happens like null pointer exception or like array index out of bounds exception, that kind of thing. That's what those are. That's how we're going to go into fixing those. Then there's going to be logic errors. We're going to go into fixing things like your mini tester failing and that sort of thing. Then there's also writing testers. So we're also going to explain how to write a tester that will improve your grade in Comp 250 by helping to identify possible logic errors. Right off the bat, does anybody have any questions regarding the, well, testers, logic errors, exceptions? What is the difference between a tester and a debugger? If there's any questions about this stuff, now is the time. Okay, so I'll assume that that part is relatively clear. We'll get into identifying errors. So a compile time error is an error which happens with a visible red underline. It doesn't let your program open. If you're in Eclipse or IntelliJ, you'll have your code that causes compile time errors to have a red underline. You can see the details of a compile time error by hovering over the line that has a red underline. Usually they're caused by typos and bad syntax. So they're the kind of thing that should be like pretty clear to identify just if you look at other Java code and compare it to yours, or if you're using IntelliJ, there's usually automatic fixes which are suggested. Then runtime errors are different. Runtime errors happen when your program opens and it's like having a null pointer exception or an array index out of bounds exception or something while your program is running, or a class cast exception, whichever one, right? Those happen while your program is running. Now how do we fix these? We can make testers and debuggers. Here are some important terms. We have the stack trace, which is the printout when your program is finish running. When it crashes, it has that red text in the console. That's called the stack trace. The debugger is a tool which we can use to fix bugs. Basically, breakpoints are a line where the debugger will pause and show you the values of all your variables. And then we have step controls, testers, try catch. This is something good to screenshot and reference, but it is something we'll get into in a practical level soon. Next, I'll just show you kind of what interface we're working with and the step-by-step of how to use the debugger. The first step is we have to assign a breakpoint. So what a breakpoint does is it pauses the program at a given line. It's like, you know when you guys debug and you put system out print line after, let's say, a bunch of things that you consider to be important? Well, instead of doing system out print line, what you're able to do is you're able to put a breakpoint on that line. And when you put the breakpoint on the line, what it does is it pauses the program when it gets to that line. And that will allow you to actually see the value of all the variables in your program at that time. It'll freeze it right then. So to do that, you have to click next to your line number. You see the red dot next to line 21 in that screenshot there? You have to click next to the line number, and then it will pause on that line when it gets there. To do that, you have to click the bug icon when you open your program. So you see in the second screenshot there, I've got an arrow pointing to the bug icon. So first you click on the line where you want the red dot to be, where you want it to pause. Then you click the bug icon. That's going to launch it with the debugger. Then we have debug controls like step into and step over, which we'll go into in our practical example where we're writing an array list. And then we also have our variables view where we can see our variables both in line with our code and on a variables page in our IDE. And again here, I'll just mute my overlay so that you guys can see everything. I've got another screenshot of the user interface where we can actually see where everything is. So in the purple here, we have where we can view our variables. In the blue here, I've got my step controls, which is how we can navigate between our lines. Our blue line as well is our current line. In the red, highlighted here with the line numbers, is where we put our breakpoints. And then in the purple, we have where our variables are visible. Yep. And then, I think the green is where you run it. So hopefully all that is clear. If it's not, you can always go back and reference these slides, and we'll get into a practical example now where we write an array list. But before I get into it, do we have any questions? All right, so what we're doing again is to use the debugger to write an array list, and we'll write a tester for our array list as well. And our tester will help us confirm that our array list is working properly. Our debugger will help us to identify the problems that our tester shows us. So let's start creating our array list class now. I'll call mine bad array list. Bad array list. And our bad array list is going to store, let's say, strings. So we'll start with a string array. So string list. And right away we're getting, issues. Our program will not open. If we want to do this, we can write a tester that'll let it run. And I'll just put my main method in my tester class here. And I'll try to create an array list. So public tester, or public void main, public static void main string args. Your tester is something that you want to run, right? So your tester needs a main method, whereas your data structure usually doesn't even have a main method. But yeah, again, right away, my file has a red underline. In my tester, if I say bad array list, a is equal to new bad array list, well, right away, this one will compile, but if I try to run it, it's going to give me an error. And what is that error? Well, let's try to figure it out. I know this might be a review for some of you guys, so just stick around for a second, and I'll get through the compile time errors. We'll get to the interesting stuff in a sec. It's just for people who are struggling with this kind of error, like symbol not found and all of these sort of compile time errors. The issue is that there is no class with a lowercase s. Here, my typo was just not capitalizing the s on string. These kind of errors are super common. There's also common errors where you might forget a semicolon. And here, some IDEs will actually put the red line underneath your curly bracket as well. But the point is, you have compile time errors that can happen anywhere in your code, and they're usually due to bad syntax, like having no proper semicolons, bad variable names, bad class names, that kind of thing. Alright, so that's just the basics of a compile time error. Now let's see what a runtime error looks like. First I'm going to just create the basic methods of my array list though. So can somebody tell me what is the function of an array list, what should it do, and how should it work? Alright, so an array list, right, is an array that can grow and shrink, right? So when you have an array list, it's not just an array, which is a fixed size, which you allocate once you start your program. An array list is a special kind of data structure where once you add to the like too large of an index, the array list is going to grow. It's kind of similar to what you guys are doing in your assignment. So what we need to do is we need to have, let's say, a method for adding something and a method for removing something. And we probably want our list backend thing here to be private. So we'll say private string array list. And here we can actually create our methods. So let's say public void add, and we can add a string to our list, string to add. And I'm just using a string as whatever thing we're adding. Like this can be whatever we want. Right? We'll have an add method, and we'll say, why not just say list at list.length minus one equals to add. Now we'll see if this is right or not by using a tester. The tester will help us develop our code. And then while we're at it also, we probably want to remove methods. So let's say public void remove, string to remove. And also notice that when I'm doing these, I'm making sure that my variable names are actually useful. A lot of the time people might just put string s or like string st, and they might just put these variable names that are short, but that don't really describe what you're using. And that's not necessarily a great practice. First, I'll show you why it doesn't actually take any longer to use long variable names. If you have a long variable name like to remove, you get your code suggestions up right away. So you can just press enter on that, and it writes out your full variable name. So don't worry if your variable name is long. That's okay. It's not going to take you longer to type it because you can just use the code completion for that. And by having descriptive variable names, you can better understand what's going on. So here I can say, let's say for int I is 0, I is less than list.length, I++, and I'm just going to do like my very basic understanding of the remove method, something that's like a straight up reading of the pseudocode. If you look at the slides, I'm just kind of reading through it, and I'm doing the very bare minimum to get it to kind of sort of do the right thing. So I'm going to say if list I, and I'm making a lot of mistakes here, but we're going to find them using our tester and our debugger. If list I is equals to remove, and then even IntelliJ is telling me that I'm making mistakes, but it's okay. We'll use the debugger to find them. And then we'll say list I is equal to null, right? So this can be my remove method. Why not? So these are bad. These are not necessarily correct, but let's see if they work in our tester. Well, let's say, oh, we're forgetting our get method. So let's also create a get method. Public string get int I. We'll just get the thing from that index of the array, so return list I. And then with these three methods, we can create a bit of a test. We can see, do all of our functions work? So first, let's see if adding works. We can say string test is equal to hello world, and we'll say a.add s. Now we can see that our code has no compile time errors, right? All of it will compile. It's fine. It's going to run. But can somebody tell me, do you expect us to have errors in this code? Do we expect to have problems here? Or is our code just going to run flawlessly first time? And if you do expect some problems, maybe which problems might you expect? What do you think might cause us problems? Should we use dot equals instead of equals equals? Yeah, that's a good option to do, because again, a string does use dot equals to compare it. In fact, if I hover over my equals equals here, it even tells me that I should replace equals equals with dot equals right from my IDE. So yeah, even my IDE is telling me you should replace it with a dot equals. So that's a good call, and that's a good thing for us to point out. But there are actually other problems. Let's see what happens when we run our tester, because it might not immediately be obvious without the tester why it's going wrong. We run it right away, and we get a null pointer exception. Now these are super common, but I'm going to show you guys how to deal with any null pointer exception you want. Remember here, I'm going to start using the debugger, so I'm going to give you guys a quick refresher of the debugger slide. These are our debugger controls right here, up here. You should see on the page all the buttons I'm talking about. When we put a breakpoint, you see in the red circle, we have all the line numbers. That's where we click to add a breakpoint. You see in the purple, that's where we see the values of our variables. In the blue, you have our step controls, which lets us navigate through our code. And in the green, we have our run button, which lets us run with the debugger. So right here in my IDE, I've got those same buttons. You might not see all of them right away. That's because we're not actually debugging yet. Once we're debugging, the user interface will look exactly the same. So my first step, of course, is to put a breakpoint down. I want to see what's going on. So I'm going to put a breakpoint down right here on the first line. My issue does cap in at line 5, but I want to see what's happening before line 5 as well. And I'm going to use the step controls to navigate through my code. Now that I've placed the breakpoint down, just by clicking next to my line number, same place where the play buttons go, I'm going to click the debug button right here. It says debug tester, but right up here it's just a bug icon. When you guys are working on your assignment, you guys can put breakpoints in mini tester, and that's going to help you out. I'm going to allow access. And now I can move around. So here I've got the same screen from the slides. Again, I'll show you the slide. And here's my screen. Oh, actually, there's one difference. Here, I don't have the console to the side. To do that, you can just see console up here. Normally, it's right over here. You can drag it over here to see what's in your console at the same time. So that is one difference. If you want console to be beside your variables, you can make it like that. To be like in the slide. To be identical to the slide, again, you just drag console from over here to over here. Now it looks the same as it does in the slide. And we can see the values of our variables. Right now we have no variables, right? We have args, which is an empty array. If you ever wonder what string args is in your main method, well, now you know args is empty by default unless you run it with some special arguments. And now I can do something. What do I want to do? Well, I want to step into, let's see what the constructor of bad ArrayList does. By stepping into, I enter whatever method is on this line. So here, since I have the circle bracket, since I'm calling the constructor, by calling step into, I'm going to enter the constructor. So could somebody tell me where is this going to take me? Like if I click step into, where will it take me now? Well, step into is going to actually take me into the constructor of my bad array list. Shy group today. It's okay, guys. So it's going to take me into the constructor of my bad array list, which actually does not exist. But because I have a default constructor, I don't have any set. But I have here still a view of my variables, and I can see every variable that's established. I can see my list is null, which is probably a problem. And I can see what else is going on. So now if I click step over, I get to my next line. My next line creates the variable test. So right now I can see as my variables get created, I've got more and more. So now I've got my variable test, which is a string. I've got my variable a, which is a bad array list. And here I'm going to add test to a. So you can see on this line I use both a and test. And that's why next to it I have information about a and information about test right here in my view. So you see, guys, how the debugger gives us the values of our variables right in line with our code. When we run with the debugger, well, the blue line is our current line, and on the current line we can see the values of all our variables. And as we go back through, we can see the values of all our variables just by clicking on them here on the side. And if something is not visible in our code, we can also see all the variables listed down here. Alright, now we want to see what's going on with add, right? Because in our issue right here, in our exception, it said that our problem was caused by the method add. You can see that by reading bad ArrayList.add. That's what caused our problem. So I'm going to enter the add method. And it says right here, null pointer exception. So what does this mean? Could somebody tell me what's going on here? Why does it say null pointer exception next to list? List hasn't been initialized. That's right. That's a great observation, and we can actually see that because list is null. That's right. So can somebody tell me when does a null pointer exception happen? And you're welcome to come on the mic if you'd like. I know it's a shy group today, but for the recording, let's get some people on that mic. Again, the question is why is it that null pointer exceptions can happen? What causes a null pointer exception? Well, a null pointer exception is caused by having a null value that we call a method on. When we try to access a null array, so when we try to do this square bracket array access on null, or when we try to call a method on null, like if we tried list I dot equals and list I was null, it'll cause a null pointer exception because we cannot run a method on null. So that's why this is causing a null pointer exception. And you're completely right that it's because it hasn't been initialized. So how could we go about initializing our list? What step could we take? Quality. We would need a constructor, yeah. So we can't just live with our default constructor. We gotta make one. So public bad ArrayList, bam, and we can say list is equal to new string 0, right? Because it's empty at the start. Initialize it with an empty array. Now we have our constructor. Now if we rerun with the debugger, we can actually watch what's going to happen. Let's see if we get a null pointer exception this time. Or we can even rerun without the debugger. So if we use the regular run button, it's going to ignore our breakpoints. But now we get an array index out of bounds exception. So clearly our method of just adding to the length is bad. But right here, even my IDE, this is like an IntelliJ thing. It asks me to find out why it could be null, or if I find out why the length can be -1. And that is, well, a fancy IDE thing. We're not going to go into IntelliJ's automatic helpers with that. You can use them for the course, but I'll teach this to be more of the general skill. So we won't use the automatic like find out why things. Instead, what we will do is we'll just use the debugger and we'll figure out why are we getting an array index out of bounds exception now. We go in, and I am going slow with this to show you all the exceptions, and this just gradually finds our way through exceptions and finds out what's going on. How do we identify a array index out of bounds exception? Well, here's how. First, there's two things we're checking, right? Our array and our index. When we have an array index out of bounds exception, we can look at our array, hover over it, so we can just hover over list, and we can see we've got an empty array, length 0. So no index is valid. Now, what index are we trying to access? We hover over the minus to get the value of the expression. We have -1. So we can see right away we're trying to access index -1 with an array of what length? An array of length 0. So length 0 array at index -1, no bueno. So we have to do something. We have to increase the size of our array while this runs. And this is the core idea of an array list. So why don't I say list equals new string list.length plus 1. And now if I try it like this, I'm just going to run it quickly. Great, we get no exceptions. But how do we know it worked? Well, that's what a tester is for. Now we can say if a.get 0 does not equal, and remember we were using the correct equals, does not equal test system.out.println something went wrong, right? And if you see what I'm doing here, I'm saying that if the string I put into my array list is not inside of my array list, I have to say something went wrong. Else, I will say let's say system.out.println all is well. All is well. Right? So we'll see. Is it working? Is it not? When I run it, we shall see. Okay, so we've passed our first test. We've successfully added something to our array. Now we can increase our test's intensity. But before I do that, I've got to go into one bit of coding practice that's very important, and that is break your code down into methods. Don't just have everything in one big method. I say break it all down. Why do we do this? It makes it so much more readable and so much more understandable. So what I'm going to do is I'm going to take this out of here. I'm going to create a new method. It's going to be called private static. It can be public or private, doesn't matter. Simple add test, and it's going to be void. And we'll put all that code in here. Now I'm going to call simple add test. Why did I do this? Well, because of that, I can also add now a bigger add test. Let's say complex add test. Now, can somebody tell me by what way could I improve my add test? What could I do to test my add more thoroughly? Is there some edge case I could do or some other case I could use to check my add in a way that is more useful than just adding one thing? Well, what I could do is I could actually add multiple things, and I can see if they're all still there. So a good way to do this is to just initialize our own little array. I'm going to call it string test subjects, and I'll make it a new string, and this is some syntax that you may or may not have seen before, where we initialize array to already have stuff in it. So here I'm going to initialize this array to have hello world, comma, let's say hi tutorial, good luck on A1, maybe a couple strings like this. Debugger is the best. Right, so 4 of these strings in here, and we're going to test that all of them are still in it after we add them all. So we can say for string s in test subjects. Why do I do a for loop like this? It's because I don't care about my index. I just want to access them all. So I'll say, I have to also create my array list. So bad array list A is a new bad array list. And we'll say a.add s. And now we're going to see. For int I equals 0, I is less than, we need a size method. So this is a good reminder that we need to know how big our array list is. So let's do that. Bad array list will have a public int size, and we'll return list.length. Right? I is equal to a.size, or I is less than a size, I plus plus. And we'll say if a.getI is not equal to test subjects at I, system.out.println, array add went wrong. And let's see what happens now with my complex add test. Looks like another null pointer exception. And this is why testers are useful. See, the better the tester, the more issues you can identify. Imagine this is like your mini tester, and this is like the tester we use to grade you. See, they're doing the same thing, right? So the mini tester here, in fact, I could even call it, let's say, refactor, rename, add mini tester. And this one can be like refactor, rename, add grader, right? So imagine that the add grader is doing this much more complicated test than the mini tester. Now this is obviously not the real tests we use. We actually do ones that are quite a bit more complicated than this one, but we can see the difference, right? So this is why we care about writing our own testers beyond the mini tester, because they test more thoroughly. But now let's investigate this null pointer exception. So could somebody tell me, what should I do? How should I investigate this null pointer exception? How should I solve it? Well, what did we do for our previous null pointer exception? For our previous null pointer exception, we used the debugger, we put a breakpoint on our tester, and we used the step controls to see why we get a null pointer exception. We can do the exact same thing here. So I'm going to put a breakpoint on here. I'm going to click the debug button, and that is going to let me iterate through my code, or basically run through my code with the steps, and see where my null pointer exception happens. So it looks like so far all of my adds work fine. I can even step into and I can watch it add. So I can say that the length is 2. My list is currently full of nulls. That might be a little spoiler as to what's wrong, but it's okay. We can actually see in the debugger the values of everything. We can see the value of the string I'm adding. We can see the value of list.length plus 1, which is 3. We can see the value of list. Empty array, yada, yada, yada. We go through, we add. And see, I don't have to step into. I can choose to step over or step into. Step into takes me inside the method. Step over takes me to the next line. And now I'm iterating through my bad array list. And here's where I get my null pointer exception. It's when I call getI. So let's enter that method. I'm just going to skip right on over. I'm going to skip through this for loop. And I'm going to enter the method. So what happens when I get I? Return list I. I is 0. That means list I is null. That's our problem. Let's look at our list. it says it's null, 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 debugger is the best. So why is this happening? Well, since stuff is not getting properly added, we can see that although we're testing whether stuff is there, yeah, we're seeing that stuff is not properly added. So only the last thing is actually in our array list. Let's find out why. We can run the debugger again, but this time we can just put a breakpoint on the add method. We don't have to put a breakpoint here. We can just run it like this with the debugger, and we'll get to our breakpoint. And now we can watch what happens. So the first one looks like it adds just fine. We look at our list after we add it, and our list will contain hello world, right? So step over, and our list contains hello world. So it looks like our first add went fine. Now here's a new button that you haven't seen before in the debugger, and that is this button, the resume button. This is going to run your program at full speed again. It's not going to pause anywhere until it hits the breakpoint again. So we're going to resume the program, and then it's going to stop next time we get to add. And our array list, our list still looks fine. Our list contains currently a string, or is it fine? Right now our list is, oh no, our list is, no, it's fine because we're adding this again. So our list contains hello world and null. So whatever's happening, it's not keeping the first values. So how do we fix this? Well, we actually have to use a temporary variable. So we'll have to say temp, so string temp, and if we want to exit the debugger screen, we just press the stop button. So we'll say string temp is a new string, and then we have to copy over all the previous elements. So we're going to say for int I equals 0, I is less than list.length, I++, and we're going to shallow copy our variables right into there. So I'm going to say that list or temp at I is going to be equal to list at I. Right, now we've copied all over all of our variables, and then we add our new one to the end. Let's see if that worked. Oh, it didn't work. Let's see why. We're not going to do the find out why, although that is cool and you can learn it on your own time. But yeah, I'm going to go into here, and I'm going to see. I've run the debugger again, and we want to see why do we get an array index out of bounds exception right away from the very start. Well, list.length minus 1 is -1. Oh, I see why. We're using list instead of temp. So I created the temp, but I didn't use it. Silly mistake, but the debugger let me see that. Now I'm going to run it again, and it's going to see if it works. Another array index out of bounds exception. Let's see why. List.length minus 1. Oh, well, this should also be temp. See, I didn't even need the debugger there. I could just read my stack trace here. These are also pretty useful. They tell us what line things are happening on, and they also tell us why they happened. And if you see the lower down, it's called a call stack. So we start in this method, so it happened inside this method. Well, what happened inside this method? Inside this method, we tried to add to test. What happened when we tried to add to test? Well, we tried to access the -1 index, and we got an exception. So this way we can kind of pop back out and see what exactly was happening in our code when we got our exception. But now, hopefully it'll run well, and let's see. Oh no, still no bueno, still not good. Which method are we having problems with? Well, we're having problems with our get method. Let's see. What is wrong with our get method? We don't need a breakpoint here now. Let's put a breakpoint on the line we're having a problem on. So our problem is on line 11 of the mini tester. So let's see. Stop and rerun. Don't want one here. If you have extra breakpoints, you can just get rid of them. I'm going to go right here, and I'm going to step into get 0. So what is currently our list? Our list currently has length 0, but we should have added to our list, but we didn't. But our add method worked. Like, we could see our add method worked. So what I forgot was I forgot to say that list is equal to temp. I forgot to swap those guys over. So now if I finally run it, hopefully I have a good add method. And it looks like it is good. We don't fail anymore. So do you guys see how the tester was able to help us develop a good add method, and how the tester was able to identify problems in tandem with the debugger? All right. Now we can go on to remove. Now remove is a challenging method, and it's both challenging to write and it's challenging to test. But I'm going to do this a little bit backwards. I'm going to write the tester first and then the method. This is actually a great way to write your code because you know what your code is supposed to do before you actually write it. So remove mini tester, and this is going to let's first add everything to our array. So we can just copy paste this over from our other one. Right. Now we can pick one to remove. Let's say a.remove test subjects at index 0. Let's just remove the first one. And now we can say for int I is 0. We'll do the same for loop, but now we can fail if any of them are equal to test subject at 0. So if the one is still there, we can say that our one to be removed was not there, or I guess was there. Now we can see if it's going to run. I'll run tester again, and I'll add my other tester over here, remove mini tester, and we're going to run it. Oh, and we got a null pointer exception. All right, so this is getting old already. I've seen null pointer exception debugging 100 times, so I'm going to go fast on this. All right, speed run. If you want a slower one, please watch the earlier part of the recording where I go through it slowly, but now I'm going to do a bit of a speed run. I'm going to get I. Let's see what get I is. It's null. Why? Well, because we removed it. Okay, so I can see the problem. When we remove something, we're just making it null, and that's going to cause a null pointer exception. How do I know this? I look into here, and I see, what is the value of list I? It is null. What is our list? Well, it's got our last 3 elements, and it's got null. Here we can see that what we did was we removed test subjects 0. What is test subjects 0? Well, test subjects 0 is hello world. Is hello world present in bad ArrayList? No, it's not. But you see what I'm doing here on the side? I'm clicking between these perspectives, not here. I'm clicking between these perspectives. What is this doing? Well, remember in our stack trace how we had these 3 different lines? We had main, remove mini tester, like that. Well, in debug, we actually also have access to this. So right now, we're inside of remove mini tester, but inside of that, we're doing this line, and inside of that, we're doing this line. It's kind of like the movie Inception, if you guys have seen it. We're like at different levels. It's like a method within a method within a method, and it can go for a long way. And we can see here, yeah, again, we're deeper and deeper into our methods. At the deepest level, we're returning whatever is at list I, which is null. At the level above that, we're comparing null to test subject 0, which gives us a null pointer exception. And at the level above that, we're just running remove mini tester. So do you guys see how the levels of these method calls look? All right, so let's go on about fixing this problem. We've identified our issue that our remove keeps a null in here. So I think our remove might have to be modeled after our add. Let's try it. Let's just try to make it the same as our add, and then change it from there. So we can say it's going to be -1, right? Because when we're removing, it needs to be smaller. And then we can say for int I is less than list.length, I++, temp is equal to list I, but we only want to do this if temp is not the one to remove. So if temp, if list I does not equal the one we want to remove, and remember we noticed that dot equals is what we should be using here, does not equals the one we want to remove, so the one we want to remove will be hello, or I guess no, we don't want to hard code it, we want to say to remove, then we will copy it. But before I do that, I'm actually going to demonstrate why we use dot equals, so I'm going to do an equals, or I guess an exclamation mark equals. And we're actually going to debug that. I know you guys pointed out earlier that we should use dot equals, but I'm actually going to show you why we use dot equals. And now we can just say that, yeah, list equals temp. Perfect. All right, let's run. And we get another exception. Well, what exception is it now? Let's see, index 3 out of bounds for length 3. And where is it called from? Well, the problem happens on tester line 38, right on the remove method. Let's debugger it, and let's see why. We enter the method using step into. We've got our array of strings. We go into here. And why are we getting an array index out of bounds exception? Our list.length is 4, and we're going into the length of our list. Oh, I see the problem, because we should probably be going into the length of our temp, because we're copying into temp, right? So Now if I rerun it, let's see if it works. Ooh, null pointer exception. Not good. Not good. Let's see why. Well, I'm not going to click find out why. I'm just going to debugger again. Enter a.getI. And list I is null for index 0. Okay, that's very interesting. So it looks like our first item never actually got copied over. Or it got removed improperly. But it probably did get copied over because we tested our add method. So what could be going on in our remove method to make it so that our first element is null? For I equals 0, I is less than 10 with length. If I is not, I see why. Let's actually watch our remove method run, and maybe we can understand it as well. So if I run remove, let's see what happens. We're trying to remove hello world, which is the first thing in our array. As we step through our method, we also get to see temp. So temp is all null. It was just created. And I is 0. When I is 0, this condition, let's see, is to remove equal to hello world. True. So it's saying that, indeed, hi tutorial is not the same as hello world. So we're going to carry that right on over. But I is already 1. When I was 0, I guess I missed it there. We have to step back. When I was 0, they were equal. So step over, step over. So I is 0. Let's see this condition. Yeah, okay. So indeed, this is false. So it's not going to do whatever's inside the if statement. So the index 0 of temp will never be set. So I guess what we also have to do is we have to do an else I minus minus maybe. That could work, but that's just going to halt our I. Instead, we probably want to have a flag for whether it's been removed or not. So that adds a little bit of complexity to our code, but I guess it's needed. So we can say boolean was removed equals false. And now here we can say else was removed equals true. And now we can maybe also say, what can we do? Well, we need to access our index differently. So we have to say that if list I is not equal to remove, we can set the thing. But of course, we also have to skip it over and take the thing into our temp. So what we might have to do is we might have to say if was removed else, right? And now we have an if else block where we can change our indices a little bit based on whether it was removed or not. We can say if it was not removed, we just do it normally, and if it was removed, we can say temp at I minus 1 is equal to list I. List at I. And now let's see what happens. We're going to run it. And we still get a null pointer exception right on a.getTestSubjectsI. So again, it's a lot of our debugger. We just, every time we have this problem, we can use our debugger. We can get I. What's wrong with I? List I is hi tutorial. It's fine. It works. Okay. Now we can try again. Or we can just see the value of our... Okay, I see. It's our last one. So we can see the value of our array. Let's see the value of our array when this happens. We're going to get to here. We're going to step into get. And list is null at the end. So what's happening here? Temp I minus 1 is equal to list I. But now, oh, I see why. Because list.length is actually what we needed to do. So you can see where I'm changing stuff around, but I'm seeing why using the debugger. I don't have to do any system out print lines. I'm doing this slowly and messily. But finally, I got it to run successfully. And now, great job. I've done my code. Are we done? No, we're not. We have to do a better tester. So this was just our mini tester. I'm going to show you guys another cool technique to create a really powerful tester. Private static void remove grader. And it's going to test every possible edge case. How am I going to do this? Well, I'm going to test every possibility. For int, and I'm going to call it, let's say, to remove equals 0. To remove is less than, I'm going to put test subjects on the outside. To remove is less than test subjects.length. To remove plus plus. Right, and it's going to try to remove every single one. So every time we're going to redo our same loop. But instead of hard coding it to test subjects 0, we're going to say test subjects I. Test subjects I, and now I have a compile time error. Or not test subjects I, it's test subjects to remove. So remove test subjects I, test subjects to remove, and my A is not set, so I have to create that here. So what I'm doing here is I'm looping through every possible thing to remove in my array here, and I'm gonna try it. So I'll also maybe add a null, and no, I'm not gonna be that cruel. But I'm also gonna add hello world again. Or am I? No, I'm not. I'm gonna do something cruel as well. I'm gonna do one test as well, and it's gonna be called remove greater 2. So private static void remove greater 2, and I'm gonna demonstrate why we use dot equals. So what if I want to write it like this? What if I want to say, let's say, gonna establish my array in the same way, but now instead of removing it like this, let's say I'm using the terminal. Let's say I'm interacting with my app, and I want to remove hello world. So I can type a.remove hello world, right? And we expect that the string hello world that's in the array will be removed, right? Does everybody see how the expectation is that when this runs, hello world is removed? Well, actually, I have to say new. I'll just do new strings in case Java tries to optimize it. But yeah. So the original is hello world, and here we're removing a new string. If I run this with the equals equals, these two are actually two different strings, right? So it's not going to work. It's only going to work if they are the exact same string in memory. So now if I do the same test, which is right here, we'll see if it works. And this is testing whether we removed correctly or not. And I'm going to add these two remove testers, remove greater 2. I'm not going to add remove greater because it's going to be too intense. It's going to fail us. But let's see what happens. Yeah, it looks like it's broken. It looks like it's broken because our tester, let's see, which line of our tester? Because our remove is trying to remove something that's not there. Does everybody see how it is? When we don't use dot equals, it's going to try to remove something that's not there. It's not going to do a good job. So if I replace this with dot equals, and we run, it's all good. So do you see why dot equals is important here? Again, equals equals, or exclamation mark equals here, crashes. Dot equals does not crash. Why? Because now it's comparing the strings based on what's in them rather than their memory address. All right, one more thing we want to probably do that this pointed me to was that when we don't remove something, it crashes, right? Like if we're not actually going to remove something, well, then it's not gonna work properly. So I can do this. If it was removed, it equals temp. If it was not removed, it equals list. What does this do? It says if the thing was removed, we set list to temp. Else we set list to stay the same. And now, even if I use my exclamation mark equals, it'll work. It'll still be bad because it won't remove it. But it will not crash at least. Or will it? No, it'll still crash because our for loop was bad. And that's something we'll have to fix. But since we're running out of time, I'm going to run through my mega tester as well. And we'll see how that works. And then I might defer to my previous recording for remove to give you guys some time for questions if you have any. Else I will actually finish this. So here we go. We're going to run our remove greater. And actually, lo and behold, our remove greater does work. But now I'm going to add another little spanner to the works. I'm going to add a remove greater 3, and that's going to remove something that isn't in the list. And we're going to see how that works. So instead of removing this that is in the list, we're going to remove something that's not in the list. So I'm going to say not in list. And this one gets people. Like this is seriously killer. Like it gets people a lot to remove something that's not there. That's usually where people lose grades. So let's see if we lose our grades here. Oh, I don't run it, that's why. Let's run it. Remove grader 3, remove grader 2, remove grader 1. So remove grader 3. And there's also other tests you can throw to remove, but these are just the common ones. Do we have an issue? Yeah, we do. Let's figure out this issue, and this will be our last ArrayList problem. And then afterwards, well, from our tester, we should be able to tell that we can be relatively confident that it works okay. We're going to get rid of this breakpoint. When there's a check mark next to the breakpoint, that means we reached it. We're going to enter remove grader 3, and we're going to see what it does. It creates a new bad array list, yada, 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 adds all the strings to it, great, and then it calls remove. Let's enter the remove method, and let's see what's going on here. So we've got our list, or our temp here. Our temp is going to be 1 smaller. Our temp is all empty, and that's great. So was removed as false. It just moves a thing from the list. Was removed as false, it just moves the thing from the list. Was removed as false. And okay, I see why. So when nothing is ever removed, and we're copying the last thing over to temp, the index is too big. So we probably want this to be an else if I is still less than temp.length. And now, hopefully, that doesn't break our code. And lets us pass all the tests. And it does. So, that's kind of our semi-final array list. I mean, I can't guarantee it'll do every possible test, because you could come up with ones that will still break this, I'm sure. But it'll at least pass a relatively thorough test. We know for a fact, because of these testers, that our array list will pass. It will definitely survive removing any possible thing that's in the array. So again, this tries to remove something at every index of the array. It tries to remove at index 0, it tries to remove at index 1, it tries to remove at every possible index. Do you guys see how this test works? It tries to remove an object from the array at every possible index. We know it can remove from every index, so no edge case is lost there. And then I identified an edge case. What if we remove something that is not equals equals? What if we have something that's the same, but not the same object, right? We have the same text, but in a new object. That's an edge case. So this one is an edge case, and then this one is an edge case. This edge case is removing something not in the list. But now that we've identified 2 edge cases, and we've tried every possible normal case, we can be pretty confident that remove is good. And then with remove mini tester, we just know that it can remove 1 thing. This is redundant with our grader. Then our add is also very robust. We tried to add a big list of things, and they all seem to work, right? So we added a lot of things, and we added just 1 thing. Add is working fine. So it looks like our add and our remove are working good.